Deep in the Red Rock Canyon country, where Utah meets Arizona, behind the towering concrete arc of Glen Canyon Dam, sits Lake Powell, the second largest reservoir in the United States and one of the quiet engines of the modern American West. Most people know Lake Powell as a place of stunning beauty, a destination for houseboats and adventurers. A shimmering blue expanse threading through some of the most spectacular scenery on the continent. What far fewer people know is that Lake Powell is also a power plant, or more precisely, that the dam holding it back is one, and that the electricity generated there flows out across an enormous region of the interior West, feeding a grid that increasingly powers something new and voracious, the data centers, semiconductor plants, and technology corridors that have quietly taken root across the Mountain West and the desert Southwest. And here is the unsettling truth at the heart of this story. Lake Powell is dying. The Colorado River that feeds it is shrinking. The reservoir has fallen toward levels never seen since it was filled, and the day could come when Glen Canyon Dam can no longer make power at all. If that day arrives, there are places that would feel it, and among the most exposed, in ways almost no one talks about, are the region's booming technology hubs. This is the story of how a shrinking reservoir in the desert is bound by invisible wires to the future of American technology, and which 6 tech hubs stand closest to the edge. The hidden power plant of the canyon. To understand the danger, you first have to understand that Glen Canyon Dam, the structure that creates Lake Powell, is not merely a wall holding back water. It is a major hydroelectric facility, and its power role is central to everything that follows. Inside the dam, water from Lake Powell is channeled downward under enormous pressure through great pipes, striking the blades of turbines and spinning them to drive generators that produce electricity. This is the same fundamental process that powers every hydroelectric dam, and at Glen Canyon, it produces a very large amount of clean, flexible power that flows into the regional grid. What makes hydropower especially valuable is that it can be turned up or down almost instantly, unlike many other sources, which makes it a crucial tool for balancing the grid and meeting sudden surges in demand. A dam like Glen Canyon is not just a source of raw energy, but a stabilizer, a resource that grid operators can call upon at a moment's notice to keep the whole system steady. And that flexibility is precisely what makes its potential loss so significant for a region whose demand is growing more volatile by the year. But the way that power is distributed is what makes this story unusual and important. The electricity from Glen Canyon Dam is part of a larger federal system of dams and power plants across the upper Colorado River region. And that power is marketed and delivered to a sprawling network of customers spread across a huge swath of the interior West, reaching into Utah, Wyoming, Colorado, New Mexico, Arizona, Nevada, and beyond. The customers are not primarily the giant coastal cities, but the municipalities, the rural electric cooperatives, the public utilities, and the tribal communities of the interior. This is the power that helps keep the lights on across the vast, high, dry heart of the American West, the region between the Rockies and the deserts, and it is precisely this region that has become, over the past decade or two, one of the most important and fastest-growing frontiers of American technology infrastructure. The clean, cheap hydropower of the canyon and the hunger of the modern data center have found each other in the same geography, and that convergence is what puts the tech hubs of the interior West at risk if Lake Powell dies. The entire arrangement depends, however, on one fragile variable: the level of the water in Lake Powell. The higher the water, the greater the pressure, and the more power the dam can produce. As the reservoir falls, the pressure drops and the generation declines, and there is a critical threshold, the elevation often called minimum power pool, below which the water can no longer reach the turbines at all, and power generation stops entirely. Glen Canyon Dam sits closer to that threshold than most people realize, and as the reservoir has fallen through the long drought, the possibility that the turbines could one day go silent has moved from a distant abstraction to a genuine and studied concern. To grasp why, we have to look at what is happening to the river itself. Why Lake Powell is dying. The threat to Lake Powell is not a matter of speculation, but of a long, measurable decline that has been unfolding for years. Lake Powell is filled by the Colorado River, which gathers its water from the snowpack of the Rocky Mountains in the upper basin states and flows down through the canyons of the upper river before reaching the reservoir. For a century, that flow has been the lifeblood of the entire Southwest, but the river has been chronically overused, promised to more users than it can actually supply. And in recent decades, it has been gripped by a prolonged drought intensified by a warming climate that pulls ever more moisture out of the snowpack and the soil. The consequence has been a steady, alarming fall in the level of Lake Powell. Sitting at the head of the system, the reservoir catches the shrinking flow of the upper river directly, and in the driest years it has dropped with frightening speed toward the critical thresholds that would compromise the dam. At certain points during the drought, Lake Powell fell to within a relatively thin margin of minimum power pool, the level at which Glen Canyon Dam would lose its ability to generate electricity, and water managers scrambled with emergency measures. Releasing water from reservoirs even further upstream and adjusting the flow downstream simply to keep Powell high enough to keep making power. This is what it means to say Lake Powell is dying. It does not mean the dam will crumble. It means the water behind it could fall so low that the turbines can no longer turn, and the power that flows across the interior west could simply stop. The reservoir sits at the front of the line for the river's decline, exposed and vulnerable, and its power output hangs on the thin margin of water above the intakes. And as we will see, what hangs on that same margin, in turn, is the electricity feeding some of the most power-hungry facilities ever built. The insatiable hunger of the modern tech hub. Before we can understand why the tech hubs of the interior West are so exposed, we have to reckon with a fact about modern technology that has crept up on the world almost unnoticed. The digital economy runs on staggering and rapidly growing amounts of electricity. The cloud, the internet, artificial intelligence, streaming, the entire weightless-seeming world of data, none of it is actually weightless. It all runs on physical machines, housed in enormous buildings called data centers, and those data centers consume electricity on a scale that is difficult to comprehend. A large data center is essentially a vast warehouse packed with thousands upon thousands of computers running around the clock, every hour of every day, storing and processing the data that powers modern life. These machines draw immense amounts of power simply to operate, and then they draw enormous additional amounts of power to keep cool, because all those running computers generate tremendous heat that must be constantly removed to prevent the equipment from failing. A single large data center can consume as much electricity as a small city, and the newest facilities built to train and run artificial intelligence are more power-hungry still, pushing demand to levels that strain the grids around them. And the number of these facilities has been exploding as the world's appetite for data and computation grows without limit. The technology industry has, in a very real sense, become one of the largest and fastest growing consumers of electricity on the planet, and every new data center, every new server farm, every new chip fabrication plant adds to a demand that must be met by the grid. This is the crucial link. The interior West, with its cheap land, its cool, dry climate ideal for shedding heat, its tax incentives, and above all its historically abundant and inexpensive electricity, including the hydropower of dams like Glen Canyon, has become one of the most attractive places on Earth to build these power-hungry facilities. Data centers and technology campuses have sprouted across the region, drawn by exactly the cheap, reliable power that the Colorado River's dams help provide. And that means the fate of these facilities is now bound, however indirectly, to the fate of the reservoirs. The tech hubs came to the interior West, in part because the power was cheap and plentiful. And the power was cheap and plentiful, in part because of the great dams. If the dams falter, the foundation on which those tech hubs were built begins to crack. With that connection understood, we can look at the 6 hubs that stand closest to the edge. The first hub, Salt Lake City and Silicon Slopes at the top of the list, stands the Utah Technology Corridor, centered on Salt Lake City and stretching south through the suburbs toward Provo, the region that has earned the nickname Silicon Slopes for its remarkable concentration of technology companies, startups, and data infrastructure. Utah has become one of the fastest growing technology centers in the country outside the coasts, home to major software firms, a thriving startup ecosystem, and a growing constellation of data centers, and it sits squarely within the region served by the Upper Colorado River power system, of which Glen Canyon Dam is the crown jewel. The connection here is especially direct, because the very administrative heart of the federal power system that markets Glen Canyon's electricity is based in Salt Lake City, and Utah's utilities and communities are woven deeply into the network that distributes that power. Silicon Slopes grew up in a state where power has historically been abundant and affordable, a condition that helped make Utah attractive to the technology industry in the first place. As the region's data centers and technology campuses have multiplied, their appetite for electricity has grown enormously, adding to the demand on a grid that draws part of its supply from the Colorado River's dams. If Lake Powell were to fall below minimum power pool and Glen Canyon's generation stopped, the loss of that clean, flexible hydropower would ripple through the regional grid that Silicon Slopes depends on, forcing utilities to replace it with other, often costlier and less clean sources, and adding stress to a system already straining to keep pace with the technology sector's relentless growth. As the largest and most prominent technology hub in the heart of the power system service region, Silicon Slopes stands first in line among the tech centers that would feel the loss. The second hub, Cheyenne. Wyoming, the second hub, may surprise those who do not follow the geography of the data economy, but it is one of the most important in this story. Cheyenne, the capital of Wyoming, has quietly become one of the significant data center hubs of the interior West. Major technology companies have built large data center campuses in and around Cheyenne, drawn by the state's cheap power, cool climate, wide open land, and favorable business conditions, and Wyoming sits firmly within the upper Colorado River Basin and the region served by its power system. Wyoming's inclusion illustrates a broader truth about the modern data economy. It does not cluster only in famous coastal cities, but seeks out precisely the places with cheap, reliable electricity and cool climates, which are exactly the conditions found across the high interior West. Cheyenne offered all of that, and the technology giants took notice. Building facilities that consume enormous quantities of power in a state whose grid is part of the same interconnected system that Glen Canyon's power flows into. The clean hydropower of the Colorado River dams is part of the mix of resources that help supply this region, and the loss of Glen Canyon's generation would remove a valuable, clean, and flexible source from the grid that Wyoming's data centers draw upon. For a state that has bet part of its economic future on becoming a home for the data economy, the health of the region's power supply, including the hydropower that a dying Lake Powell would take away, is a matter of real consequence, and Cheyenne earns its place among the tech hubs most exposed to the reservoir's decline. The third hub, Phoenix and the Arizona Corridor, the third hub, takes us south into the desert, to Phoenix and the surrounding Arizona Corridor, which has become one of the most explosive centers of technology infrastructure growth in the entire United States. Greater Phoenix has attracted an enormous wave of data center construction, and beyond the data centers, Arizona has become a major destination for advanced semiconductor manufacturing, with vast and staggeringly power-hungry chip fabrication plants rising in the desert. Arizona is one of the states served by the Colorado River power system, drawing a share of the electricity generated by the river's dams, including Glen Canyon. The Arizona Corridor represents perhaps the most intense concentration of future electricity demand of any place on this list, because it combines two of the most power-hungry industries imaginable: massive data centers and cutting-edge semiconductor fabrication. A single advanced chip factory can consume electricity and water on a scale that rivals a small city, and Arizona is building several, alongside a booming data center industry, all in one of the hottest climates in the country, where the cooling demands are already immense. This makes the region's need for reliable, abundant power absolutely critical, and it makes any loss of supply a serious concern. The clean hydropower from the Colorado River's dams is one contributor to the vast pool of electricity the Arizona Corridor draws upon, and the loss of Glen Canyon's generation, coming on top of the region's already soaring demand and its brutal cooling needs, would tighten an already strained supply. As one of the fastest growing technology and manufacturing hubs in the nation, sitting in the desert that the Colorado River sustains, the Arizona Corridor stands squarely among the places most exposed if Lake Powell dies. The fourth hub, Albuquerque, New Mexico. The fourth hub is Albuquerque, New Mexico, a city with deep and long-standing roots in technology and science that has grown into an important center of the interior West's technology economy. Albuquerque and the surrounding region are home to major research institutions and national laboratories engaged in some of the most advanced scientific and computational work in the country, as well as semiconductor manufacturing and a growing technology sector. New Mexico is one of the states within the Colorado River Power Systems Service region, connected to the same network that carries Glen Canyon's electricity. New Mexico's technology and research infrastructure includes some of the most computationally intensive work anywhere, the kind of high-performance computing and advanced manufacturing that demands large and reliable supplies of electricity. The national laboratories and the semiconductor facilities of the region are significant power consumers, and the growth of the broader technology sector adds to that demand. As part of the region served by the Upper Colorado River Power System, New Mexico's grid draws on the clean hydropower that Glen Canyon provides, and the loss of that generation would remove a valuable resource from the supply that Albuquerque's technology and research institutions rely upon. In a state where advanced computation and manufacturing are central to the economy and to some of the nation's most important scientific work, the reliability of the power supply is a matter of genuine importance, and Albuquerque takes its place among the technology hubs that would feel the impact of Lake Powell's decline. The fifth hub, the Colorado Front Range. The fifth hub is the Colorado Front Range, the corridor stretching along the eastern edge of the Rocky Mountains that includes Denver and the technology-rich communities around it, most notably Boulder. This region has long been one of the most important technology and research centers of the interior West, home to a dense concentration of technology companies, aerospace firms, research universities, federal scientific laboratories, and a thriving startup scene, along with a growing data center presence. Colorado is, of course, one of the upper basin states at the very source of the Colorado River, and it is fully within the region served by the river's power system. The Front Range technology economy is broad and deep, spanning software, aerospace, telecommunications, scientific research, and advanced computing, and it represents one of the largest concentrations of technology employment and infrastructure in the interior West. The region's data centers and research computing facilities consume substantial electricity, and its continued growth adds steadily to the demand on the grid. As a state at the headwaters of the Colorado River and within its power system's reach, Colorado's supply includes the clean hydropower of the river's dams, and the loss of Glen Canyon's generation would remove part of that clean, flexible resource from the regional grid on which the Front Range depends. Given the scale and importance of its technology sector, and its position at the very source of the river whose decline threatens the dam, the Colorado Front Range stands as a major technology hub with real exposure to the consequences of Lake Powell's death. The sixth hub, Las Vegas, Nevada. The sixth and final hub returns us to the desert, to Las Vegas, Nevada. A city better known for its lights and entertainment, but which has increasingly become a growing center of data infrastructure in its own right. The Las Vegas region has attracted significant data center development, drawn by the same combination of factors that has fueled the industry across the interior West, and Nevada is among the states served by the Colorado River Power System, receiving a share of the electricity the river's dams produce. Las Vegas represents the collision of two enormous demands on the region's power. On one hand, it is a city in one of the hottest deserts in the country, with an already colossal appetite for electricity driven by the relentless need for air conditioning and by its vast entertainment industry. On the other hand, it is now adding to that appetite a growing data center sector with its own immense and around-the-clock power needs. This combination makes the reliability and abundance of the region's electricity supply critically important, and it makes any loss of generation a serious matter. The clean hydropower from the Colorado River's dams is part of the supply that helps meet southern Nevada's enormous demand, and the loss of Glen Canyon's generation would tighten a supply already stretched by extreme heat and rapid growth. As a desert city adding heavy data infrastructure to an already staggering electrical appetite, Las Vegas rounds out the list of technology hubs, standing closest to the edge if Lake Powell dies. What going dark would really mean. Having identified the 6 hubs, it is essential to be clear and honest about what the loss of Lake Powell's power would and would not mean for them, because the phrase "go dark" is dramatic, and it is important not to overstate the reality. If Glen Canyon Dam stopped generating electricity, these tech hubs would not instantly go black. Their data centers falling silent and their screens winking out in a single moment. That is not how the power grid works. Each of these regions draws its electricity from a large and diverse array of sources, of which the hydropower from the Colorado River's dams is only one part. The loss of Glen Canyon's generation would be a significant subtraction from the regional supply, but not an instantaneous blackout. What it would mean is subtler, and in the long run, just as serious. Glen Canyon provides a particular kind of power that is especially valuable, clean, renewable, and above all flexible, able to be ramped up and down quickly to match demand and to stabilize the grid during peaks. This kind of flexible hydropower is extraordinarily useful precisely for balancing a grid that must serve the constant, around-the-clock demand of data centers alongside the surging peaks of summer cooling. Losing it would force the region to replace that power with other sources, very often more expensive and more polluting, raising the cost and the carbon footprint of the electricity that the tech hubs consume, and removing a valuable tool for keeping the grid stable. For an industry that depends on cheap, reliable, and increasingly on clean power, for data centers whose operators have made public commitments to running on renewable energy, the loss of a major source of clean hydropower would be a real setback, undermining both the economics and the environmental goals that help draw the industry to the region in the first place. There is a deeper vulnerability here as well. Data centers and semiconductor plants are not ordinary electricity consumers. They require not just power, but extraordinarily reliable power, because even a brief interruption can be catastrophic, corrupting data, halting sensitive manufacturing processes, and causing enormous financial damage. These facilities invest heavily in backup systems precisely because their tolerance for power disruption is so low. A regional grid that has lost a major source of flexible generation is a grid with less margin, less resilience, and a greater risk of the kind of instability that these facilities cannot abide. So while the loss of Lake Powell's power would not black out the tech hubs overnight, it would erode the foundation of cheap, clean, reliable, and abundant electricity on which they were built, making the region a less attractive and less secure place for the power-hungry technology infrastructure that has flocked to it. Over time, that erosion could slow the industry's growth, raise its costs, and undermine the very conditions that made the interior West a technology frontier in the first place. The collision of water, power, and data step back from the individual hubs, and what emerges is a picture of a remarkable and largely unrecognized collision between three great forces of the modern West: water, power, and data. For a century, the story of the region has been a story of water, of the Colorado River and the great dams that tamed it, storing water for the cities and farms of the desert. In the same motion, those dams generated power, and that power helped electrify the interior West. Now, in the 21st century, a third force has entered the equation: the data economy. With its insatiable hunger for the cheap, clean, reliable electricity that the region's power system provided. These three forces have become entangled, bound together by the physical infrastructure of the West, and the decline of the first, the water, now threatens the third, the data, through the medium of the second, the power. This collision reveals a fragility beneath the gleaming surface of the technology economy that few appreciate. The digital world presents itself as ethereal, weightless, disconnected from the physical constraints of the natural world. But it is nothing of the sort. Every search, every stream, every artificial intelligence query runs on machines that run on electricity, and in the interior West. That electricity is bound up with the level of water in a reservoir behind a dam in the desert. The most advanced technology of the age turns out to depend, in part, on 19th and 20th century infrastructure sustained by a river that is running short. There is a profound irony in it. The industry that represents the cutting edge of the future is exposed to the decline of the most ancient and elemental of resources, water, and the shrinking of a river that has flowed through the canyons for millions of years. The tech hubs of the interior West rose on a foundation of cheap power that the river helped provide, and as the river falters, that foundation grows less certain. Why the timing makes it worse there is a particularly dangerous element to this story that deserves special attention, and it is the matter of timing. The fact that the decline of Lake Powell's power is arriving at exactly the moment when the region's demand for electricity is exploding as never before. These two trends are moving in opposite directions at once, and their collision is what makes the threat so acute. On one side, the supply of clean hydropower from the Colorado River's dams is shrinking as the reservoirs fall. On the other side, the demand for electricity across the interior West is soaring, driven above all by the very data centers and technology facilities at the center of this story, whose appetite for power is growing at a breathtaking pace. This is the worst possible combination, a source of supply in decline, meeting a wave of demand and explosive growth. Even without the loss of Glen Canyon's power, the grids of the interior West are straining to keep up with the surge of new data centers and chip plants, racing to build enough generation to feed facilities that consume electricity like small cities and that are being announced and constructed at a dizzying rate, to lose a major source of existing clean. Flexible generation in the middle of that scramble would be a serious blow, widening the gap between what the region can supply and what its booming technology sector demands. It would force the grid to run harder, build faster, and lean more heavily on other sources, all while trying to serve a load that keeps climbing. The tech hubs came to the interior West, assuming the power would always be there, cheap and plentiful. The simultaneous decline of the reservoirs and explosion of demand is quietly undermining that assumption, and the loss of Lake Powell's power would bring the reckoning forward, exposing just how tight the margin between supply and demand has become in a region betting its economic future on electricity-hungry technology. The warning in the water none of this means that catastrophe is fixed or inevitable. The level of Lake Powell can rise as well as fall, and a strong winter of snow in the Rocky Mountains can push the reservoir back up and pull Glen Canyon Dam away from the brink, buying precious time. The states that share the Colorado River have been engaged in difficult negotiations to reduce their use of the water and to stabilize the reservoirs, and every effort to keep Powell above minimum power pool helps keep the turbines turning and the power flowing to the region that depends on it. The technology industry itself is investing heavily in new sources of power, including large amounts of renewable energy, and over time, such investments can reduce the region's dependence on any single source, including the dam. The future is not yet written, and the fate of Lake Powell's power will be shaped by the choices the region makes and the weather the mountains deliver. But the warning is clear and worth heeding. The tech hubs of the interior West, Salt Lake City's Silicon Slopes, Cheyenne, the Arizona Corridor, Albuquerque, the Colorado Front Range, and Las Vegas, have built their booming digital economies on a foundation that includes the cheap, clean, reliable power of the Colorado River's dams. That foundation is now threatened by the slow death of Lake Powell, as a shrinking river pulls the reservoir toward the level at which Glen Canyon Dam can no longer make electricity. The connection is invisible to almost everyone who benefits from it, the engineers and coders and executives of the region's technology firms. The users around the world who rely on the data centers humming in the desert and the high plains have no idea that the electricity behind it all is tied to the level of a reservoir most of them have never seen. That invisibility is part of the danger, because a threat that is unrecognized is a threat that goes unprepared for. The story of Lake Powell and the 6 tech hubs is, in the end, a story about the hidden connections that bind the most modern parts of our world to the most elemental, about the way the future is built on foundations laid in the past, and about the fragility that lurks beneath even our most advanced achievements. The data centers will keep humming, the chips will keep being made, and the digital economy of the interior West will keep on growing, for now. But the river that helps power it all is running short, and the reservoir that holds the West's water and generates its power is falling toward a threshold beyond which the turbines fall silent. If Lake Powell dies, the lights will not go out all at once. But the ground beneath the region's technology boom will quietly shift, and the hubs that rose on the promise of cheap and endlessly abundant power will slowly discover that their future was tied, all along, to the fate of a dying reservoir in the red rock canyons of the desert. That is the warning written in the slowly falling water of Lake Powell.